Welcome to this practical on registration. My name is Mark Jenkinson and I'm going to be giving you an overview of this practical. As this is the first practical in the Fsl course, I'll actually start by giving you some general comments about how we would recommend you run through these practicals. The first thing is to get up a web page which has the practical instructions. These are intended to be self-paced so that you can just go through at your own pace, working your way through these instructions. They're quite detailed so that you can understand all of the details, but of course we can't explain absolutely everything, so it still requires you to think and certainly interact with either tutors if you're at one of the courses or post messages to the list if you're unsure about any of the crucial steps. In these practicals we'll be running Fsl in order to actually process some of the data. In order to do that you're going to have to use one of the terminals. So here is the terminal program in this setup. And we would just start it like that, and that's what a terminal is going to look like. It might have all sorts of different things at this point, but the important thing is that there is something followed by a prompt. If you are not familiar with the basics of Unix or Linux, you've never used a terminal before, for instance, then I highly recommend that you go and have a look at the preparatory material on Unix and Linux before you actually interact with this practical any further. We'll also be using a range of different GUIs involved in Fsl, but they'll generally be also started through the terminal. For instance, if we just type Fsl like this, then we get up the main Fsl GUI. Within the web page instructions, you'll actually find a number of different boxes. Some of these boxes are grey like this, and they actually indicate things that you would run in a terminal. So for instance, we can actually copy that and then paste it into our terminal. And that would run the first of these commands that we see here. But there are other boxes as well. There are boxes like this which actually are flow diagrams for different commands. This happens to be the command for brain extraction, or BET. It shows what inputs are required for it and then what outputs you are likely to get from that command. Some of them are quite simple like this, others are more complicated. The idea is that they summarize what are the most important aspects of the inputs and the outputs that you should expect to see. And they're often illustrated with specifics that are relevant for this section of the practical. Other boxes that you'll find are boxes such as the asides, and they give you additional information, but they're not absolutely crucial for the main flow of the practical. And then there are also boxes which have multiple choice questions in them. When you go through this or any of the other practicals, you'll see that there are lists of detailed instructions telling you exactly what to do to fill in some of the boxes within the GUIs, for instance, or to run some of the command lines. Make sure that you actually pause whenever you're doing that and think about what you're doing. Why is it this particular file that I'm entering here? What kind of information is in that file? If you have no idea what that is and it's an image, why not have a look at it in Fossilize? Otherwise, just make sure that you can understand what it would be like if you're working with your own data, which might have different namings for some of the different files. Make sure that you understand where the information is coming from so that you would be able to actually run it yourself and understand what the command lines are trying to do and whether it's a very standard thing which would be very much the same for your data or whether it's something that you might need to actually modify. Again, if you're unsure about any of the details, please do ask one of the tutors if you're at the course or post a message on the Fsl list. In this first practical about registration, there are three main sections which you can see in the contents here. Actually, the third one is an optional extra and is really just a repeat of section 1 with different data, specifically for high accelerated multiband data. So we're really expecting people to do the first two sections, and if you're interested in the third section, then please do have a look at that, but it is optional. These first two sections relate to different parts of the lecture. The first part relates to the section on EPI distortion correction and registration, where we'll actually be running through the different stages that you have to do in order to set up the Feet Gui, that is the GUI which we use to analyze fMRI data, but only the section which relates to the distortion correction for EPIs and the registration. That is, looking at how you would set up the GUI like this, look at this kind of output. The second section looks at more general steps that we apply when we're looking at registration and particularly moving things between spaces. And that also relates to parts of the lecture. These are the earlier parts, such as this which goes through image spaces, spatial transformations and interpolations. And it culminates in transforming a mask and using that to quantify something within the hippocampus. So let's now have a quick run through of the various stages in these first two parts of the practical. To begin with, we've got this first box that we do to do CD, which is changed to a directory, and then look at the contents. We've already done that. So here we see the different files that are there, which correspond to the ones that are listed here. And that gives you a little bit of information about all of these different files. I'm not going to go through this word by word because that's something that we'll do in the practical. This is just a quick overview. So have a read through that and look at the various different images. So for example, we can type fossilize in the terminal here. If I put an ampersand at the end, then I get my terminal back and I will start fossilize. Once fossilize is up, I can load any image that I want. So here I'm going to look at the structural and open that just so that you can see what it's like and that all of my labels are correct within that image, and I can have a look around. And please do that for all of the different images so that you get a feeling for what's in your data. It's always a good idea to have a look at your data. The first step here is actually going to be preparing the structural image. And so to that we need to run brain extraction on it. And you'll recognize this as one of the recommended preliminary steps. We have already run reorient to standard on this data that you have, but in practice you should do that. And then we're going to do the brain extraction step on it now. So you should be familiar with how to run brain extraction from the preparatory practicals. And it's as simple as going into your terminal. You can just type bet, and I can do struct as the image that I want. And then I want to call my output struct underscore brain. So I'll just expand that terminal so it's a little bit easier to read. There we have, that's the command I'm going to run. I just press return, and that's now going to take a very short amount of time, and now it's finished. You can tell that by the way that I've got my prompt back. Now I want to have a look at the results by actually loading it here. So now I can look at struct brain, I can open that, and I don't immediately see anything because actually if you load two things in fossilize, you see through the background of one of them. So it's best if I turn them both off. If I turn each one on in isolation, I see what's there. So that's my original structural, and now this is my brain extracted one. So that's useful to see it like that. Or I could turn them both on, and the alternative way of viewing it, which I quite like, is to give the brain extracted one some color, and then you can scroll down to just see what the quality of that brain extracted image is like. And you can see that it's not perfect. There are parts where it gets non-brain material within the mask, but for the purposes of registration, this would be perfectly fine. It's the first part of just preparing the structural image and looking at the results with fossilize. In the next part, we're going to look at field map images. So I've loaded these already, and this is what they look like. This is the magnitude image, and it looks like a fairly normal but poor brain scan. And this is the phase map, which really doesn't look like a normal brain scan at all. It's fairly uniform except in the inferior frontal and temporal areas. The next part of the practical looks at processing the field map magnitude in order to do a brain extraction, but a very tight brain extraction. And so we actually recommend doing that in two stages. One, by running the brain extraction tool that we've seen before, and then by actually making it even tighter by running this erode command. Within my terminal, I would first of all start by running the brain extraction command on this magnitude image and calling it mag underscore brain. As you can see, I don't bother typing the .ni or .gz at the end. That's not necessary. You can either include it or not in any of the Fsl commands. And now I'm going to take this command, and now we're going to look at the result of that. So I've loaded the results here. This is my original magnitude image. This is now my brain extraction of that, and you can see that there is some non-brain material included in that mask. And then here is my eroded one. And you can see that that's much tighter. Then you can see what the erosion has done. It's really just taken the edge away from that original brain extraction. And that's important for us because actually what we really want to do is avoid these noisy parts which are just around the edge of the brain. You can actually see in this phase map. And if I turn this form of brain extraction on, then actually a lot of that gets included within this red, which I don't want. If I turn this one on, then I exclude these areas. And that's what this section is going to do. So work your way through and make sure that you can see the same things when you do the processing. After that, there is some processing of the phase difference image. Actually, we're going to use a special script called Fsl Prepare Field Map, which is useful for Siemens field maps. If you don't have a Siemens scanner, that's fine. There are other ways to process your field maps, and details of that are given on the Fsl wiki. But for this data, it is from a Siemens scanner, and so that's going to take you through that process. The next part is using the Feet GUI itself. So I'm going to start by going to my terminal and typing feet with a capital F, and that's going to bring up the GUI. If I was on a Mac laptop, I'd actually have to type feet underscore GUI, and that's really about the only difference between using a Mac or using a Linux box. So this is my Feet GUI now. The first thing that it says within these instructions is select pre-processing at the top. And so that's what I'm going to do here. Select pre-processing, and you see that it blanks out a couple of the tabs because it's not going to do anything beyond the pre-processing. And it leaves a range of different tabs, and we're going to look at each of these in turn. Most of what we're going to do is actually on this pre-stats tab. These diagrams illustrate what's happening behind the scenes with some of the registration. And then a lot of the detail here is about how to actually enter the various different bits of information. And that's going to take you through the data tab, where you actually input your 4D data, which is your functional data. The pre-stats tab, where we're going to turn binaural warping on, and we're going to enter the various different bits of information, just as was shown in the lecture slides. Then we're going to eventually fill in the information on the registration tab. We're generally not worried about the miscellaneous tab because there's not much in there that we would normally change. So we're going to work our way through these three different tabs, and that's what this text is all about. And it takes you through the various different things that you need to input there. But again, think about what these contain, where they've come from within the steps that you've already done, and how you might get that information if you were running your own study. So once you've followed all the instructions, then you're ready to hit go, and you're simply going to get that, and it will automatically open a web page report for you. Back in our instructions, what it says to do here is to actually do something while you wait, because actually that can take around about 15 minutes to finish. In the meantime, it's telling us that what we can do is have a look at an example which has already been generated and saved, and that's going to open a report. And so what we can do in this report is then we can look at the various different things. So on this first page you can see a lot about the registration which has happened, and that's what we're interested in for this practical. But you can also see further details of what's happened with the binaural unwarping or the distortion correction here. So again, these are the same kind of images that we've seen in the lecture, and this will allow you to actually interact with those and go through the process of seeing what it's like and comparing it to the one that you're actually running yourself. And as well as that, to look at how to load different images within Fossilize itself. And once you've run through these instructions, then you'll actually end up with something like this that you can look at in Fossilize, where you've got different versions. So this is the distortion corrected one, and this is the non-distortion corrected one, and you can flick through those, looking at various places such as these areas at the front of the ventricles, and you can see how much better these areas are aligned when you've got the distortion correction on. Then once your feet job is finished, you'll be able to actually have a look at the results from the run that you just performed without the non-linear registration, and also compare that. And then there are some multiple choice questions to answer based on that. And that's the first part of the practical. The second part of the practical looks at applying and inverting transforms. This is related to the section of the lecture which was looking at different spaces, how you can transform things between spaces, how you can have inverse transforms, and move things such as masks between the different spaces. It's actually going to look at the output from a feet registration already, such as the ones you've just been doing in the first part. And in order to demonstrate how to actually move a mask between the different spaces, we'll start by creating a mask of interest. And we will do that by using Fossilize and some of the Atlas tools. The purpose being just to create a mask which we can actually transform between the spaces. Once you have a mask, then there are some other steps that you need to do in order to actually get the mask into the space that you're interested in. So here we'll be looking at how we actually invert a transform, and that's inwarp in this case. And this section will show you how to use that. Following that, there's applying a transformation, and that's again a simple command called apply warp. And you'll notice that these are all ones which run in the terminal, so they're all in these grey boxes. Again, all of the details are here for you. All you have to do is copy and paste. Note that whenever you've got a backslash like this, it's actually a shorthand for being able to break a single line into two lines just for display purposes. If you're cutting in or copying and pasting, then you need to copy and paste all of that just as usual, and that's fine. If you're actually typing it out for any reason, then you should not include the backslash. So that's true not only for this thing, but for any portion of any practical where you see something like that with a backslash. Once you've used this, then again, there's a visual check. Then we're going to look at thresholding that to see what the final output looks like. We can see the functional image, and here is the result of actually aligning the mask that we generated in standard space of the hippocampus into that functional image. And here's what we would get after we've run the binarization. So that result in green is after we've done the binarization, and here we have the mask before. And finally, we're going to use this mask in order to extract the average time series. It doesn't have to be the average time series, it could be the average of anything within the hippocampus. We're just using it as a binary mask or an ROI in order to create some average. These tools are very general, and you can apply them in various different ways to calculate various different things or to move things between different spaces. Finally, the optional part at the end, as I said before, is a repeat of the very first section, but now with multiband data that has a very high acceleration. And in this example, we were really going to go through the same process that we did in the first section, but now we need to look at a different image in order to do the registration well, which has better contrast. In order to illustrate that, I'm loading the two different functional images, the functional scan itself, which is the main 4D one, the multiband functional, and then one specific high contrast volume that we use to help the registration, which is this contrast func. Here they are loaded into Fossilize. I'm actually going to play with the brightness and contrast, which is what I normally do in these images. Some of the examples before, I've done that before without showing you, but this is generally what I would do. So there we are, that's just showing things a little bit nicer for that contrast one. And now for the multiband. So this is the one we're actually analyzing the 4D data for in order to get our functional data. So this is optimized in order to give us very good T2 star contrast, but as you can see, the anatomical contrast is much worse than we get from this scan, which has a much nicer grey-white contrast that you can see in various places. And so this scan, this contrast func, or a pre-saturation scan, something which happens at the very start of the sequence, often thrown away in other sequences, but for multiband, very useful to keep, because it gives us something that the registration will work much better with. Getting the registration between these two images, then the contrast func and the multiband, is trivial, and we are actually going to be able to get a much better registration by using this contrast func. And so we're simply going to go through the same process that we saw in the first part of the practical and repeat it, but now inserting the contrast func into the appropriate place within the GUI. And so if you're interested in that, then I recommend going through the third section, this optional one about multiband. And that's the first practical.